Right. Is it working? Yes. So thank you everybody for being here tonight. We are very happy at Algoa to host that kind of meetup, and we are used to do that. We have a few meetups every week. Currently, it's kind of crazy, but we like that. So if you are also organizing meetups, just let us know. We are happy to host you guys. Today, before presenting, the indexing challenge of instant search, which is exactly what I'm going to talk about in a few minutes, I just wanted to talk to you about what is Algoa, because you all joined that wonderful office. I hope you like it. At least we are liking it a lot. Here at Algoa, we are doing a hosted search API. So basically, we are building a search engine that is hosted on the cloud, and we are providing developers with an API that helps them build the search inside their website or application. So instead of handling all the infrastructure and all the relevance tuning on your side with an open source solution, we propose you to have a state-of-the-art, Google-like, Amazon-like experience by using of technology. We focus a lot on speed, and you will see that instant search, the search that you have, at each keystroke, the search that you have on Google, on Amazon, is not that easy to do. And if you have NLP knowledge, you probably know a little bit about all the issues you can encounter with that. But we also focus a lot on relevance. Relevance is key today. If you have a fast search engine that is not relevant, doesn't need to be, you don't need to be proud of that. We focus obviously on the ease of integration, and the thing with Algoa is that we have that strong infrastructure that lets you have the same search experience wherever you are on the planet, basically. So we are doing a replication of your search engine across our 15 data centers, and we are allowing your users wherever they are to have and experience the same search experience. Today, our infrastructure starts to be pretty massive. We have 50 data centers in about 15 regions, and that's about a bit more today than 600 servers. We are processing every month 42 billion API call, and we have a lot of customers, about 2,100 spread into 100 countries. We have a lot of logos, so I don't know if you guys are used to use Medium, PHPOC, DigitalOcean, but all those guys are using Algoa either for the search on their website, like the main search, like on medium.com, but maybe also in the documentation search, like on DigitalOcean. If you're using Periscope, you are also using Algoa while searching for lives, because we are also handling geo search. So that was Algoa. And again, because we are a search engine and because we focus that much on speed, we have designed from the ground up a search engine that is able to handle instant search. I want to help you understand how we are doing that. Before I want to explain you a little bit about indexing, because search engine, even if we are using them all day long, it's still something that maybe you didn't implement so far, and that's fine. So I'm gonna do a quick introduction about indexing, and we will see a few drawbacks of the other alternatives. So indexing. I don't know if you think about the same thing that I'm thinking right now when I say indexing, but what you should think about is it's exactly that. You have a book and you want to search efficiently for all the pages where you have some words. And to do that, you basically go at the end of the book, there is the index. The process and the goal of the indexing is exactly that, is store some data in a very efficient way, so it's optimized for search. And the book that you have at the end of the index that you have at the end of the book is exactly that. If you want to find in which page there is something, you just find the word, and then there is the list of the pages where that word is. Technically speaking, the indexing process is basically the goal of that process is basically to create a data structure that will contain a mapping of each word to a list of documents where the word is present. So that's called an index. And a search engine contains several indices. Search as you type. So I was telling you that we at Algoa are so fast that we can implement the search as you type. It's Google that first introduced that in 2010. They called that first Google Instant. It has been renamed later to Instant Search. It's basically, as soon as you type in that search bar, the results are already coming. And you don't even need to finish the search. You didn't even need to press enter. Google has already understood that the few letters that you have typed will probably result in those results. With Algoa, it's exactly what we provide, what our API lets you do. So that's two demos that we have done. One is just a simple drop-down menu that auto-completes, some movies in that case. The second one is more a full instant search results page, which is like an e-commerce demo, where as you type, we refresh the whole page, being the hits, but also the navigation capabilities that you would have. And all of that in real time, wherever you are on the planet. So how to implement instant search? The first thing you can think about if you are a little bit used to NLP and information retrieval is that from a list of entries that you want to search in, a list of documents or a list of objects, and an indexing technology, by combining those, you will have a search engine. And at query time, if my query is RE, I can definitely look in the index, all the words starting by RE, find that two words are matching, and do a OR query in my search engine, which will result in that case in the query retrieval or retrieved. And that's easy to build. The issue with that is that it can produce very complex and slow queries, because depending on the number of words matching your prefix, so searching RE, maybe here we have 2 words, but I don't know how many words on the internet start with RE. It's a lot. Okay, so you don't want to end up with a query with like so many OR components, and that's why this solution will be working for very small data set, but it's definitely not something that will scale. Another option to implement instant search is what a lot of people, including open source solutions like Elasticsearch, are implementing. It's called either an autocomplete model or a suggester model. And here it's all about a try. So I don't remember, or I don't know how far your data structure knowledge is, but a try is a data structure optimized to store a dictionary which associates strings or words to something. So in that case, if we take that same list of entries that we want to instant search, that we want to autocomplete, and we store those entries into a try by having one letter, in every single edge, you are able to build a suggester. And with that suggester, you can, when I type my same query than before, RE, you can definitely go into the R branch, into the E branch, and say, okay, once I'm here, I know by construction that every single object and words that will match my prefix query will be those ones. Pretty easy to implement if you have the right data structure. The only issue with that is that you will need to type exactly the entry like it is at construction time. So if I have in my construction, this is the first title, I will have THEIS space is the first title. So I will have a long branch, which means to find that object, I will need to start by searching by the exact same words that start the sentence. It's pretty fast, but it's not really easy to tune, especially when you are dealing with relevance. Imagine you want to include here typotolerance or synonyms or NLP or linguistic extensions. It can be complex. Another option that is used in the industry to implement instant search is basically, instead of indexing in an index all words, you would index all prefixes of words. So for instance, if I want to generate all the prefixes of the word test, I will generate test, TE, and T. So by doing and computing all the prefixes of all my entries and storing that in an index, I'm ending up with an index of all the prefixes associated to all documents containing those original words. At query time, it's becoming super easy because RE, my same query than before, will have an exact entry in my prefix index. And then retrieving the documents that have RE is very easy because it will be stored directly in my index. So at search time, it's very, very efficient compared, for instance, to the first solution where I was expanding the query to all words matching or starting with RE. But in reality, that kind of approach will increase drastically the index size on disk. And today, to be efficient, everyone does that, including Google. You need to have the whole index into the RAM. By computing all the prefixes of all your words and storing that in a big index, you will just explode in terms of RAM consumption. So not a good option as well. Something slightly different, but still the same, is to compute, instead of prefixes, n-grams. That basically helps you to just stop generating every single prefix, but just say, okay, I want the prefixes, but maximum size of n, or minimum size of m. But again, it's the same kind of results. Very efficient at search time, little bit less consuming than if you naively generate all the prefixes, but still very heavy, and into the RAM, it will never fit. So let me tell you how we did it at Algoa, because I invite you to test it on those customers that we are dealing with today. It's instant and it's so fast. So the goal is, how do we combine all those options and make something efficient, both at search time, indexing time, and without consuming so many RAM? One thing that we have done is basically move away from a trie data structure to a radix tree. A radix tree, another name of that is Patricia trie. It's basically a trie where you will compress all the letters that are on the same branch without children. So for instance, instead of having FAST, because no words are starting by the same letter, I have a single branch, a single edge with fast. So instead of having letters in my children of every single node, I have substrings. But that's not enough, because from there, I didn't solve really anything. Obviously, I will have less nodes in my memory, but that doesn't really solve the problem. But something that you may notice here is that those internal nodes that are sometimes just used to branch and sometimes just used because here is the word faster, it's in document 1, and here is document faster, which is so fast in document 1 and faster in document 2, we can probably leverage those internal nodes. The goal is basically to store into the internal nodes the list of results that you would have if you do the search across all the children. So basically in that node, we will say, yes, document 1 is matching, but also document 2. And in that node, I will say, yes, document 3 is matching, but also document 4 and document 5. And in that node, document 4 and document 5. What is cool with that is that radix tree, you are able to generate it in a very efficient way without storing everything in memory while building the trie. To build a radix tree, you will first start by sorting all your words that you want to put into the trie and start adding one by one the words into the radix tree. You will first here start by adding the word fast. Then if you add the word faster, it will use the same branch. And after fast, it will just do another branch with ER, because the document 2 has the word faster. Then if you add the word test, you are basically creating a new branch that goes to the document 3, test. And at that specific moment, because you are adding the words in a lexicographical order, you have a way to basically flush the upper branch to the disk and remove it from memory, because you know that by constriction, you will never go again into that branch. And at that specific time, you are also able to flush into the internal nodes all the document IDs that you would find into the leaves. In average, obviously, the index is slightly bigger, but compared to the prefix indexing, n-gram indexing, it's like not that big. In average, we are increasing the size of an index by 20%. In terms of indexing time that you would need to build that, it's not that big as well. In average, we are only adding a 12% increase of the time of the index building. And that's how we did instant search at Algoa. Do we have time for questions? 15 minutes. Wow. Okay, I can handle it. You mean in terms of oh, wait. So to ask the questions, we have that catch box, so catch it. And you speak on the mic. Yes, it's...
Is this a mic? Oh,
yes.
I guess it is. Okay. Did you benchmark different languages to see which was more performant than another?
So are you speaking about the languages used to build the engine? Yes?
Well, it could be to build the engine, but certainly for tree search.
Okay.
Yeah, tree search is the most critical path, right? It takes the longest time.
Mm-hmm. So just for the info, the engine of Algoa is built in C++. It's a totally custom search engine, nothing to deal with Lucene, Solr, Elasticsearch. And it's embedded in an Nginx web server to handle HTTP connection, because we are still an API. To answer your question, like, do we have different performances depending on the language that we index? The answer is probably no, we didn't see anything. What we are providing developers is an API that is language agnostic, and that works approximately the same for every single language. So it's just about going down to in the tree. Then depending on if you have enabled typo tolerance, depending if you have enabled synonyms, those are all features that we provide, you may experience different search time or query time. But in average, you will probably spend less than 20 milliseconds in the Algoa engine, whatever the amount of data that you have in the index. So the goal is now to throw that catch box to that guy. Wow.
How about when you type a wrong word?
Say that again?
How about when you type a wrong word?
So indeed, if you search for something that is not in the tree, you may experience like a no results page. But obviously, that's something that we want to handle natively at Algoa. I didn't speak about it because we have only 15 minutes. But by default, the Algoa search engine handle typo tolerance. So we have a very efficient way to go down the tree and allowing typing mistakes. So even if you have typed, I don't know, LE, and in the tree there is only LA, we might go there and say, okay, I went to that branch, but that cost me something, a typing mistake. And therefore, we are able to provide you, like Google does, search results that are maybe matching exactly what you have typed, but also something that matched approximatively.
Thank you.
Okay, that's a big one. Wow.
So my question was really close to his question because so you don't handle typos.
We
but
do.
Why don't
We
you
do.
have
We do.
like?
We do.
Oh, you do.
We do. I didn't explain it here because
Okay.
it's like another 30 minutes talk.
Yeah.
But yes, we do handle typo tolerance.
Because why don't you have like a probabilistic approach? So using recurrent neural networks or anything that would like understand the context of the word and not not the whole word, so that you can like.
Yeah. Most of the time, using that maybe simple approach is way more efficient. If you want to go, at a context level or concept level, you may go for a synonym feature, which allows you to say, okay, when I search for New York, it's exactly the same than searching for NYC, the abbreviation. So you would probably go for that if you're using Algoa. Doable. Oh.
Hi. So how do you compare with Elasticsearch?
Yeah, great question. I really recommend everyone today to go to the elasticsearch.com website. What you will see there is a big data analytics platform. They are focusing on indexing billions lines of log with Logstash. They are focusing on building dashboards like Kibana. They are providing graph capabilities since the V5 and maybe a few betas before. We are not dealing with big data and log indexing. We are providing you with a technology that helps you build the end user search bar, the one that is user facing, the ones that you're used to use on Google, the one that you're used on Amazon, and the one that you don't find anywhere else because they are not yet using Algoa. Yes. Does that respond to your answer to your question?
Thank you.
In terms of performances, it's still a great tool, and we're using it for a few analytics purposes, the Elasticsearch engine, because we are doing analytics and visualization. But in terms of pure performances, we have designed our engine to be able to answer in a few milliseconds. So we have internally built the engine so that most relevant objects are always very first in the query processing, and that allows us to stop after a few milliseconds, have a timeout, and be sure that even if that timeout triggered, we have always the best results.
Yeah. So a question about the language. I'm Chinese, so I'm curious about how do you treat the Chinese?
Yes.
Because for the index, the first thing is tokenization. And what do you do for this part?
Yes. So indeed, Chinese, Japanese are languages where you cannot really split words with spaces or punctuations. They may not have any of those spaces or punctuation. So one of the big issues with search engine is handling those languages. What we do at Algoa is a mix of different techniques, but basically you can index ideograms by ideograms, and you can also try to segment the list of 8 ideograms by using a segmenter provided, for instance, in the ICU Unicode table. And you could then go for advanced and linguistic based segmentation. What we have done so far is handling simplified Chinese and traditional Chinese, and basically moving from one ideogram simplified version to a one traditional version is kind of a typo. So we handle that like we would handle typo in English. And otherwise, we use the Unicode table for most expansions.
Thank you.
So what do you think is Algolia's biggest advantage compared to Google search, Google Instant Search?
Yes, so Google is definitely the great search engine that we all use for web search. Like, you don't know a website that you want to find for something, you would use Google. But once you are inside the website, once you are dealing with, an e-commerce website, you are on Conforama, and you want to search a refrigerator, they have a search box. You may want to use their search and not the Google one, because those guys should know everything to provide you the best experience. with Algolia, they are able to inject in our engine and inside the ranking some internal data that they are the only one to have, like number of times the object has been sold. There is no way Google has that. Number of times the page has been viewed. Maybe Google has that because of Google Analytics, but still, if they have that data, we let them, build the search inside their website to search into their objects and not like on Google where we would search for only pages.
Can you talk about the optimal number of milliseconds and what you would get if you, instead of 20 milliseconds, you were able to do more work in that time frame?
So by default, we have a timeout at 50 milliseconds. So there is no way that any query in the Algolia engine takes more than 50 milliseconds. We are able to go down as far as 1 or 2 milliseconds if we disable typo tolerance or if the index is pretty small. In average, like I said, is like 15 milliseconds. The time is mostly spent because of typo tolerance and all the branches that you could visit because you are handling, typing mistakes. So if we would like to go further, we may look at that. We have a few other optimization in mind, but we are already pretty fast.
What's the tree depth that you are at, and what do you prefer?
I don't have the answer, to be totally honest. Since we are letting our users push whatever they want, they may push, English, French, and we know that the average word size is maybe 5, 8, 10, I don't know. But they can also push like their e-commerce product reference, which is, alphanumeric word of, I don't know, 16 or 32 digits. So really, it's not really an issue for us, and we are happy with them pushing whatever they want. I don't know if there is a preference. Obviously, for any try data structure, the most prefix you share between words, the better it is, because you have less nodes.
So what about relevance? What kind of algorithm or computation do you execute to match documents?
Yeah. So I would love to do another talk about relevance next time. Relevance is something really tricky in the NLP or information retrieval world, and we have been working in the search engine industry for the past 10 to 15 years, depending on me or founders or people in the room. What we have seen so far is that the statistical approach, the one that you have by default in Elasticsearch or in Solr, is well designed for document search. The one that you don't really know, how to rank, and you assume that because of statistics, because those statistics will rank the results based on length of the document, number of occurrences in the document, length of the query, blah, 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 you will have relevant results. We don't do that. We have no statistic algorithm in the ranking formula of Algolia. Instead, we are leveraging a few ranking criteria that are both textual, and that's our job, or business, and that's basically the job of the developer that push the data, being the sales count, being number of views, number of likes, whatever is relevant for their business to impact relevancy. And we merge that into a tie-breaking ranking formula where we will apply one criteria after another. There is an awesome blog post about that on our blog. So if you want to know more about ranking and Algolia, just Google like Algolia secret sauce, and you will find our blog, blog.algolia.com. And if you want to use the Algolia engine, obviously go directly to blog.algolia.com and use the search bar. Last question?
Yeah, last one. It was quite similar. I just wanted to, a big difference in Google is the ability to fine-tune the suggestions. So it's not just, algorithmic. Sometimes it comes from business considerations because you want to promote something. So my question was about how you blend business consideration in the index, and how easily can you rebuild the index at wish?
Cool. So that's indeed a very interesting question. And today, every customer that we talk to are like, okay, I want the Google-like experience, the one that is fast and relevant, but also the one that is personalized, the one that you don't have the same result if I do the query or you do the query, just because we have favorited, viewed something else, and therefore results will be impacted. Also in the e-commerce industry, just because it's Black Friday in 2 days, people are saying, okay, on the search iPhone, I want that particular object to be first. Whatever the relevance, whatever the number of sales, whatever the number of likes, I want those results to be first. Because we are an API and because we let them configure the ranking formula in a very efficient way, they can do that. They can say in the ranking formula, if the object is promoted equal true, put that first. If the object has, if the user has viewed or put into the favorites those categories while searching something, boost those categories and put them first. So really personalization and customization of the search relevance is core, and Algolia has been designed to tackle that. Thank you very much.